Hi, today we'll discuss Chapter 12, Analysis of Variance, or we also call it as ANOVA. Previously, the procedures to test the difference between two population means and proportion using either Z distribution or the T distribution has been discussed in Chapter 8 and Chapter 10. For Z distribution, the requirement to use it is the sample size n is greater than and equal to 30 and the population standard deviation is known. For T distribution, the requirement is sample size or n is less than 30 and the population standard deviation is unknown. This chapter will explain the procedure to test the difference between three or more population means. Previously, for Z distribution and T distribution, we compare two or one population means. But today, we will compare three or more population means. For example, a mathematics teachers in the school have decided three different methods to teach geometry. They want to find out if this method produces different mean scores. To test this hypothesis, we use a method called the analysis of variance or ANOVA. We don't use Z test or T test due to several reasons. One of the reasons is because of the populations means, number of population means, and the variance. Later we'll discuss why. And ANOVA will use a F distribution in performing the test. The F distribution is a continuous and skewed to the right. The F distribution has two number of degrees of freedoms. That is, we write like this: degree of freedom equal to A, B. The two number of degree of freedom are the parameters of the F distribution. The unit of F distribution are always non-negative. Why always non-negative? Because here, skew to the right. The F value obtained is called the critical value for a test of hypothesis. The ANOVA procedure is used to test the null hypothesis that the means of three or more populations means are the same against the alternative hypothesis that not all population means are the same. This lecture discussed the one-way ANOVA since only one independent variable or factor is being analyzed. If two independent variables are analyzed, then this is called the two-way ANOVA. To use the one-way ANOVA, the following assumptions must hold true. First, the populations from which the samples are drawn are approximately normal distributed. Second, the population from which the samples are drawn have the same variance. Next, the samples drawn from different populations are random and independent. In one-way ANOVA, the variation among the sample means is measured by a weighted average of their square deviation about the mean of all the sample data. The measure of variation is called the treatment of mean square of between group variance, or we also can write it as MSB. To compute or calculate the MSB is equal to SSB divided K minus 1, where K is denote the number of different samples or treatment, and SSB is the treatment of sum of square, where this is the formula for SSB. No worries for the formula. I will upload the formula sheet that I will provide in final exam to you in Spectrum. Please check the Spectrum. Besides, the measures of variation among the sample means, a measure of variation within the samples must also be obtained. The measures is the poor estimate of the common population variance, and this measure of variations is called the error mean square or MSE. MSE is calculated by equal to SSE divide n minus k, where n is the total number of observation. SSE is called the error sum of square, and the formula for SSE is like this. If you notice, here we have N1, N2 until Nk, standard variance for what? First sample, second sample, third sample, and so on, which means that we have to calculate the variance for each sample. Later, we'll discuss this by using 3 examples. Okay. Next, we also can calculate the total sum of square, SST, and this is the formula for SST, or we also can calculate by using SST equal to SSB plus SSE. Finally, to calculate the F statistic, F test is equal to MSB divide MSE, with the degree of freedom K minus 1, N minus K. This degree of freedom very important because later on when you want to find the critical value for F tags from the table, you have to refer to this degree of freedom. And after calculate all this SST, SSE, SSB, MSB, SSE, we have to summarize in a table, where here source of variation, between group, within group, total group, sum of square, SSB, SSE, SST, degree of freedom, mean square, and F tags value. You have to substitute inside here. Okay. If you still remember, in topic 10, we have discussed there are 7 steps to compute or calculate the Z tags and T tags. But for ANOVA, actually, we are group and summarize it become 5 steps. The first step is hypothesis testing, null hypothesis, mean 1 equal to the mean 2 equal to the mean until the last sample, where the alternative hypothesis is not all the means are equal. While step 3, we have to state the level of significance. No worry, for this alpha, normally the question will given. So please read the question carefully. Next, state the critical value. So how we find this critical value is by refer to the table that I upload in Spectrum. Check the degree of freedom here, K minus 1, N minus K. Why I ask you to refer to the table that I give is, in final exam, I will give the same table. Next, step 3. Calculate the SSB, SSE, SST. Then construct the ANOVA table. Determine the F statistic. I repeat, the F statistic is computed by F equal to MSB divide MSE. Next, making decision, which means that accept or do not reject or reject the null hypothesis. And last step, making conclusion. That's all 5 steps for one-way ANOVA test. Later on, we will discuss the example. Let us read the example. A researcher wished to try 3 different techniques to lower the blood pressures of individuals diagnosed with high blood pressure. The subjects are randomly assigned to 3 groups. The first group take medications, the second group take exercise, and the third group follows a special diet. After 4 weeks, the reduction in each person's blood pressures is recorded at alpha equal to 0.05. Test the claim that there is no difference among the means. So this is the data that given. So the first step will be hypothesis testing. Null hypothesis, mean 1 equal to mean 2 equal to mean 3. This is our claim. Why our claim? Because the question said, test the claim that there is no difference among the means. Then, alternative hypothesis, at least one mean is different from the others. Step 2, find the critical value. Since K equal to 3, K is number of group, we have medication, exercise, diet, so 3 groups. K equal to 3. N is the total sample size. How we get this 15 is 1, 2, 3, 4, 5. 5 row, multiply 1, 2, 3. 3 column, 15. So N equal to 15. Then next we have to find the degree of freedom. So K minus 1 equal to 2, N minus K equal to 12. Therefore, we can get the critical value 3.89. Next, step 3, compute the test value using the procedure. So find the mean and variance. Find the mean, 10 plus 12 plus 9 plus 15 plus 13. Then divide 5, we get 11.8. While variance, we just use the simple variance formula, which is the summation of the x minus mean square divide n. For population, summation of x minus mean square divide n minus 1 for sample. Then we can get this mean and variance. Please try. Next, find the grand mean. To find the grand mean is the summation of x divide n, which means that we add from the first value 10 plus 12 plus 9 plus 15 plus 13 plus 6 plus 8 until the last value 4. Divide total sample 15. Then we get 7.73. Next, we can find the MSP by using this formula, and we will get 80.07. Next, find the MSE. MSE, we apply the formula, then we can get 8.73. And last, find the F tax value. F tax value or F can compute by equal to MSP divide MSE. Then we get 9.17. Some students might ask, can we have a not same sample size for each group? Yes. Why yes is because now if you refer here NI, which means that each group, I don't care what is the sample size. It can be equal or 5 or can be not equal. Later on, I will show you one example that we don't have an equal sample size. I mean, this example, we have a equal sample for each group. If now we have a non-equal sample, we still can calculate it. Later on, we'll discuss this in example 3. No worries. For now, this example, let us continue to the step 4, make the decision. Since the F value is 9.17, which is greater than the alpha value 3.89, therefore, reject the null hypothesis. Step 5. Summarize the results. There is enough evidence to reject the claim and conclude that at least one mean is different from the others. A very simple questions, but very important for your final exam. For those students who confuse when we should use ANOVA, t-test or z-test, first, check the sample size. Second, check the number of groups. If the number of groups is 1, so one sample test, z-test or t-test. To decide whether we want to use z-test or t-test, look at the n. Sample size greater than or equal to 30, z. Less than 30, t. If we have more than one mean, for example, 2 means, 2 sample tests. Chapter 11. Next, if we have 3 means or more than 3, then ANOVA. Okay. This is example 2. Please try example 2. And please try example 3. Later on, I will upload the answer for example 2 and example 3. I repeat, ANOVA is very important for your final exam. Please try the example. Later on, I will show you the answer with the step. For those who have questions, you are welcome to email or send your message in Spectrum or Facebook group. So that's all for one way ANOVA. I will upload the answer later. Thank you.